IT Insights, talks on business and IT challenges with tech leaders.
Hello and welcome to yet another episode of IT Insights by Future Processing. My guest today is Dr. Dean Bartles, who is a seasoned operations professional with 4 decades of management experience in manufacturing and technology. Dean, would you be so kind to introduce yourself and your extensive background to our guests, to our
Happy to. My name is Dean Bartles. I'm currently the CEO and president of a not-for-profit called the Manufacturing Technology Deployment Group. It's a company I formed about 2 years ago as the parent company over top of the National Center for Defense Manufacturing and Machining, another not-for-profit that's been around for about 20 years now. And we have about 54 employees. We're growing. We're very excited to be running the National Additive Manufacturing Innovation Institute, which is branded as America Makes, and that's a term you can easily Google and find us. But I've had, like you said, I have about 4 decades of experience. I started out at Fairchild Republic Company in my hometown of Hagerstown, Maryland, as an industrial engineer, where they were making the A-10 airplane. From there, I joined a company that eventually became a General Dynamics company. I was hired to set up a manufacturing machining line in Egypt, and then I also did one in Turkey. Eventually, rose to the ranks and was running about 3 different businesses for General Dynamics, 3 different manufacturing operations, about 600 employees, about $600 million a year. Retired from them in 2014 in order to join a new not-for-profit that was formed in Chicago called UI Labs. And UI Labs was selected to run the Digital Manufacturing and Design Innovation Institute. I was recruited to be their executive director of that institute and design and build that institute in Chicago on Goose Island. After that, I went to the University of New Hampshire, designed and built the John Olson Advanced Manufacturing Center for them, had a brief stint at the National Tooling Machining Association as their president before the board asked me to take over the operation that I'm running now, which, as I said, was NCDMM. Now it also includes another subsidiary called Advanced Manufacturing International. So altogether, I've been away from General Dynamics after 31 years with General Dynamics. I left them about 8 years ago and have been enjoying this not-for-profit world and standing up different advanced manufacturing centers.
But I understand that the manufacturing and technology areas are, well, on your plate at the moment with digital manufacturing, with model-based enterprise, with smart manufacturing, all that sort of trends.
Yes, in fact, I was the founding chairman of the Smart Manufacturing Leadership Coalition, which is now actually part of my organization as well. I acquired them back at the end of 2020. We're focused on smart manufacturing, digital manufacturing, artificial intelligence for manufacturing. Additive manufacturing, of course, is really, really big here in the United States as it is in Europe. And we run this institute that has about 230 members, all of them focused on maturing more advanced additive manufacturing technologies.
What exactly does smart manufacturing mean today? I mean, it's pretty vague, and I guess there's plenty of takes on it. What does it mean to you? What's behind smart manufacturing?
Yes, so absolutely. So I tell people that, if you're a small, medium-sized company and you hear all these terms like smart manufacturing and also Industry 4.0, which of course is a term the Germans coined, I happen to think it's synonymous to smart manufacturing. The first step is basically all about connectivity. You want to get machines connected in such a way that you can understand what's going on. You want to get data off of those machining operations to understand how can you improve that operation. So that's the first step, getting an IoT edge device, which you can get very inexpensively connected to any machine. I don't care how old the machine is. There's a lot of data you can get off of your machine tools. Now, once you start collecting that data, analyzing that data, and figuring out ways you can machine more efficiently, the next step is really about giving your customers transparency. The large manufacturing companies that are subcontracting their work to small, medium manufacturers, they want to see that transparency. They want to know where their parts are real time in your manufacturing process. So you can actually gain a competitive advantage if you're able to offer your customers that kind of supplier transparency. I remember back when I was running one of the manufacturing plants for General Dynamics, we had very, very high volume production. So we had a dedicated machine for each operation. For example, let's say one particular component might have 13 separate operations. Well, we had a dedicated machine for each one of those. And in the future, I believe that you're going to be able to see the quality of the part that's coming off of Operation O100 as it goes to Operation O200, et cetera, on down the line. And when you have drift, as all machines do over time, before you can correct it, wouldn't it be nice for Operation O400 machine to detect that drift from the part that was just produced on Operation O300 and be able to compensate for that so that it can yield a high quality part as it moves on to Operation O500? That's the kind of future manufacturing. This not only is it all about predictive maintenance and being able to know when a bearing or something is going to fail prior to it failing and be able to replace it and fix it on the weekend shift, perhaps instead of interrupting first shift production. That's a key part of all of this, but also being able to know the quality of a part as it moves through the entire manufacturing operation, and before it ever gets boxed for shipment, the customer already knows exactly what they're getting. That's one of the big drivers behind all of this.
Thank you for that explanation. I mean, there's plenty of other, maybe not buzzwords, but trends or maybe aspects that can be vaguely interpreted when it comes to manufacturing. Another topic would be industrial AI. What's that all about?
Yeah, so industrial AI is a term that was actually coined by a good friend of mine, Professor Jay Lee. He's written a book on it. You can actually Google the book Industrial AI. But it's about developing algorithms that can take all of this data that I'm talking about and detect patterns, and then be able to automatically, sort of like in a closed loop adaptive control scenario, make adjustments to the manufacturing operation to compensate for that drift I was talking about. So that is the future of manufacturing. You're going to see more and more of this machine learning, model-based machine learning, and so-called industrial AI, being able to predict what's happening real time in your manufacturing processes and make compensations in order to yield the highest quality part possible. So you'll have less and less human intervention and more automatic machine learning, closed loop adaptive control technology.
Sounds like a broad range of benefits that include not only optimization and control of process, but also automation and gathering data. What sort of companies can tap into these benefits in the first place?
Yeah, all manufacturing companies can benefit from this. It's been a harder sell for the small mediums because there's just so much out there, and of course the big guys who they employ the experts like Siemens and Rockwell. They're able to spend millions of dollars on this technology, and they have multiple plants where they can learn. I can tell you of one company that I know that they had plants all over the world, and they could determine that some of the machining operations in one plant were more efficient than the other plant. So by using this data from these different machines, they could see what was going on and be able to sort of share the information across all the machines and all their plants, and all of them became that much more efficient. The small guys have a disadvantage. They only have a couple of machines, right? So it's harder for them to learn from multiple machines. I think the future is going to be in the form of a sharing platform. You've probably heard the term multi-sided platform. That's where you've got all kinds of different parties that are involved in sharing data so that they can all get better. My company is actually working on such a platform. We've already got over 200 companies that are sharing their data from their 3D printing processes onto this platform. Currently, only the customer that they're selling to has access to that data, which is a key deliverable. But eventually, I believe we're going to convince these companies to open up that data, share it with let's call them the smart guys, the guys that can develop these algorithms and figure out more efficient ways of doing things. And then all the members that are willing to share their data, they will have benefit of those algorithms for the machine learning that these other companies can do. So I'm anticipating that the material suppliers that make the powder, the machine manufacturers that make the actual 3D printing machines, the companies that are using the 3D printing machines, the customers that are buying from those companies, I anticipate all of these being separate parties on this multi-sided platform, and the future will be one of sharing with even with the small mediums getting involved, so that they too can learn from a much larger pool of data.
Sounds like there's a lot of disruption, out there, and the future of manufacturing looks digitized and transformated and different than today, and that would leverage a lot of technology. And how can companies ensure that they don't stay behind?
Yeah, we tell the small medium guys all the time. Listen, what's coming is customer push, right? Your customers are going to require you to start providing this data. Great example is this program that I just mentioned, where the Department of Defense wanted to buy these 3D printed parts, but there's still so much variability in the 3D printing of metal parts from machine to machine and supplier to supplier that the Department of Defense was a little bit leery about buying 3D printed parts and not being sure that they were getting the same quality from one company that they might get from a different company. In fact, the Navy did a study where they intentionally gave several of their plants that had 3D printing machines the same model machine. They gave them powder from the same lot and asked them to build the same part, and they found variability. So what the DoD said, okay, we'll buy these parts from these various suppliers, but we want this data so that we can interrogate the data to make sure that the key parameter settings, things like laser beam power, scanning speed, spot size, humidity in the chamber, all these key parameters that have an effect on microstructure and mechanical properties are maintained within a certain range during the entire print process. So that's what started this multi-sided platform I'm referring to. So if you're a small medium and you want to get in this game and you want to be able to offer your customers that kind of data, it's very inexpensive to do so. The edge device that we've been providing the small mediums on this program that we've had with the DoD only costs about $3,500. And you can hook that edge device up to any machine, whether it's a 3D printing machine, whether it's a CNC lathe milling machine. I don't care how old the machine is. There's so much data we can get off of these machines with this edge device. And then you can display that data to the person running the machine. You can display it to the frontline supervisors in their office and show them here's the key things that are going on during that machining operation. And you can spot things. And that's where AI is going to come in. AI is going to spot it before the human can spot it. So eventually, AI is going to be able to detect any kind of anomaly and hopefully make adjustments on the fly. So the future of manufacturing is going to be all about closed loop adaptive control where the machines are automatically correcting their processes.
Sounds very exciting. Sounds very disruptive. But I wonder if there's any use cases already of that modern and innovative technology. Can you share a few words about the recent implementation that you delivered? Or
Yeah, absolutely. So the DoD came to us and said, look, we realize that additive manufacturing is going to be extremely relevant in the future in certain types of situations. It's not going to replace subtractive manufacturing completely, but we're still very leery about additive manufacturing because of the variability from machine to machine and part to part that I mentioned. So they came to us and said, what do you think? How can we get a much higher level of confidence in the integrity of the parts that we're buying? So that's where we came up with this idea and said, listen, what if we monitor all the key parameter settings on these additive manufacturing machines during the entire print process, put all that data into a JSON file, distribute that data to you when the parts are shipped in a very cyber secure fashion so that your engineers can interrogate the data to make sure those key parameters were maintained during the entire print process. They love that idea. So now what we did is we developed what we call a prototype additive manufacturing supply chain. And we've got over 200 suppliers now that are in that supply chain that the DoD then can go out to them with an RFQ all through this highly cyber secure platform we've developed. And they can ask the companies, would you like to bid on these parts? By the way, if you're interested in getting a contract, assuming that your price and schedule are acceptable, you're going to have to give me this JSON file with all of this, actual data in addition to the part. That's new. That the DoD's never asked for that kind of information before. So of course the companies are hungry for the work, so many of them will quote those jobs and say, yes, we're willing to give you the data. Now, some of the data, some companies might think is sort of their secret sauce, and they don't want to share that with anybody. Okay, that's fine. However, if you want to do a contract with the DoD, you're going to have to guarantee that you will maintain all of that data for a certain period of time. For example, maybe 10 years. Because if this part fails out in the field a couple of years from now, the DoD wants to do a root cause analysis to determine what happened. They are going to then require you to provide access to that data. So some of the data you can keep, but you have to maintain it. But most of the data you've got to deliver when the parts are shipped, and that's happening today. I mean, we've got over 1,200 different parts that have been provided to the DoD through this 3-year program that we're just now wrapping up. And now, let me also explain. We've had multiple what we call OEMs, right? The original equipment manufacturers, the big guys, the companies like a Raytheon, a Lockheed Martin, a General Dynamics, a Northrop Grumman, have been on an advisory board during this entire program we've done with this prototype additive manufacturing supply chain. They're seeing the benefit of this, and they are now talking to us about, we think we might want to source our additive manufacturing parts that we subcontract out through this supply chain, because we see the value in having the ability to get all this data from the parts that are being printed. So I think that's going to be the future. That's how companies will be able to improve the timing it takes to get parts certified, because they'll have all this data to analyze. And eventually, I think you're going to see more and more people joining either the platform that we've developed, which, by the way, we're not for profit. We're not in this to make a bunch of money. We're truly in this to help the community at large get better. So that's a possibility of joining the platform that we've developed, or other competitive platforms that might also pop up.
Well, it's great to see that there are already some success stories out there, and that the technology can be leveraged to deliver uh, an incremental change in the manufacturing industry, historically so traditional, I would say.
Correct. Yes, agreed.
Thank you, Dean, for sharing your insights. It was very interesting, and again, thank you, our listeners, for being with us on this another podcast episode.
Yeah, let me just real quick tell you about one other thing that I'm personally pretty excited about. Okay,
Yes, feel free.
there's this new area, fairly recent, called ICME, Integrated Computational Material Engineering. And what they can do now with this simulation software, they can, if you give these experts that have this software, if you give them the model of the machine that you have, and you give them the morphology, the characterization of the powder that you're going to use, okay, they can run a simulation, and they can tell you, okay, if you want to have these resulting mechanical properties based on this resulting microstructure, here are the parameter settings for that machine that you should use with that powder. Now, this to me is really awesome. I mean, you can control the actual grain size and grain orientation by the parameter settings that you set on these 3D printing machines. And if you can control the grain size and the grain orientation, you control the microstructure. If you control the microstructure, you control the mechanical properties that result from that. So the ability in the future, right now it takes a lot of computer time to do this, but in the future, as computers continue to get smarter and smarter and faster, if you're able to put in all of your key properties that you want to achieve based on your machine model and your powder morphology, it'll automatically tell you, here are the parameter settings you should use in order to get those resulting mechanical properties. That to me is really exciting, and I think you're going to see a lot more of that development in the future.
Sounds really exciting, and it does sound like a direction technology and manufacturing should move towards further and further.
Exactly. And that's where, once you have those parameter settings, and then you have the model-based learning, the machine learning, the artificial intelligence going to be able to monitor the process and be able to make adjustments real time in the closed loop environment to maintain those parameter settings within the desired range. Now you got something. And I think you're going to see additive manufacturing to continue to get, more and more relevant in all things produced.
Thank you, Dean, for that extra.
Yep.
And thank you, our listeners, for being with us on this another episode of IT Insights. If you liked it, don't hesitate to share it, and feel free to drop us a line if you'd like to have another topic covered in one of the future episodes. That was IT Insights with Dean Bartles. Thank you.
Thank you.
Visit us at itinsights.tech and dive into our podcasts, webinars, and events.